Titanium shock, how China could paralyze the West's defense and robotics industries. Forget to hit that subscribe button, because today's story could reshape the future of global power. This isn't about oil, gas, or even semiconductors. This is about one rare metal, titanium, that could paralyze Western industry, collapse defense manufacturing, and hand China the ultimate strategic edge. Titanium isn't just another metal. It's the backbone of modern technology, stronger than steel, lighter than aluminum, and nearly impervious to corrosion. It's used everywhere that performance matters most: aerospace, robotics, military hardware, even nuclear reactors. Remove titanium, and entire supply chains grind to a halt. Take defense. The U.S. F-35 fighter jet, the most advanced aircraft in the world, is 40% titanium by weight. Navy submarines, missiles, satellites, and even body armor all rely on it. Cut off that supply, and military production slows to a crawl. Now turn to robotics. Titanium is the skeleton of advanced machines like industrial robots, surgical arms, and AI-driven factory automation systems. Companies like Boston Dynamics, Tesla, ABB, and Yaskawa rely on titanium to keep robots light, durable, and energy efficient. Without it, the entire Western automation push meant to fix labor shortages and bring factories back home could collapse overnight. So is this just another hypothetical nightmare? Not even close. China, Russia, and Kazakhstan together control around 65% of the world's titanium production. China alone supplies 35%, Russia 25%, and Kazakhstan adds another 5%, according to the International Titanium Association. These nations don't just mine it, they dominate the high-grade processing needed for aerospace and robotics. At the center of it all is China's Baoji Titanium Group, the world's largest producer of titanium sponge, a raw but essential form of the metal used in advanced manufacturing. The U.S., by contrast, produces less than 5% of global titanium and imports almost all its supply. The Pentagon alone sources 85% of its titanium from foreign suppliers. If China shuts the door through export bans, licensing restrictions, or political retaliation, the West faces a titanium shock that could cripple military and industrial production. Could the West simply use steel or aluminum instead? In theory, yes. In practice, no. Steel is far heavier, making robots slower and more energy-intensive. Aluminum is light, but too weak to withstand the mechanical stress of modern manufacturing. Both alternatives would require costly redesigns of robotics and aerospace components, and even then, performance would suffer. Titanium's strength-to-weight ratio is unmatched. So what are the alternatives? Let's look at Japan. Its firms like Toho Titanium and Osaka Titanium Technologies are among the most advanced producers of high-purity titanium sponge, accounting for about 15% of global output. But even Japan isn't a true alternative. It produces only 40,000 metric tons per year compared to China's 210,000. According to the Japan Titanium Society, worse, Japan's titanium supply chain is deeply entangled with China and Russia. Raw materials still flow from these geopolitical rivals. If Beijing pulls back exports, even Japanese producers could find themselves unable to scale. And if the West pivots to Japan, costs could spike by 30 to 40%, making robotics and aerospace unsustainably expensive. What about Africa? Yes, Africa is rich in titanium reserves, particularly in Mozambique, South Africa, and Kenya. But over the past decade, China has locked down mining rights through its Belt and Road Initiative. Chinese companies like CNNC and Luoyang Billions Group now control over 70% of Mozambique's titanium projects. The continent's largest titanium mine, Moatize, sends nearly 90% of its production to China for refining. Western companies like Tronox and Kenmare have a foothold, but not enough to replace China. And even if the raw material is available, China still controls the refining technology and processing facilities. The West is boxed in. Let's go deeper. Titanium's unique mix of properties, high strength, low weight, corrosion resistance make it irreplaceable for advanced robotics. From car manufacturing to surgical systems, it keeps machines light, fast, and energy efficient. Carbon fiber is a potential substitute, but it lacks heat resistance and costs more to produce. Steel and aluminum don't come close in performance. Global sales of industrial robots hit 553,000 units in 2023, with China alone accounting for 52% of installations, according to the International Federation of Robotics. A Chinese titanium export ban would force Western firms to completely redesign robotic systems and R&D, tasks that could take years and cost billions. This isn't just about raw materials, it's about strategy. China's Made in China 2025 plan is a massive push to dominate global robotics, AI, and automation. Over $150 billion has already been poured into subsidies and state-sponsored tech development. Firms like CS Robot, DJI, and Sciocen are racing to quadruple output by 2030. Their secret weapon? Controlling the inputs. By dominating the global supply of titanium and other rare materials, China is not only strengthening its own industry, it's pressuring foreign companies to set up production in China, where intellectual property and technological know-how can be quietly absorbed. The longer the West remains dependent, the more leverage China gains. The result? A quiet but powerful shift in global industrial power. Western robotics firms like ABB, Fanuc, and Yaskoa are increasingly reliant on Chinese components and rare metals. If Beijing imposes export restrictions, these firms could see costs skyrocket, deliveries delayed, and designs rendered obsolete. And that's just half the story. The other threat is Russia. Despite sanctions following the Ukraine invasion, Russian titanium, particularly from VSMP Oavisma, continues to flow to the West through third parties. Airbus, Rolls-Royce, and Boeing still depend on this supply, though often through intermediaries in India, Turkey, and the UAE. Russia provides roughly 1/3 of the world's aerospace-grade titanium, and it's found clever ways to bypass Western sanctions. Airbus CEO Guillaume Faury has publicly warned the EU not to tighten restrictions, saying it could trigger a production collapse worse than the chip shortage. Boeing temporarily suspended Russian titanium purchases in 2022, but Reuters reports it has quietly resumed sourcing through Southeast Asian intermediaries. Airbus never stopped. The reality is, without Russian and Chinese titanium, Western aerospace production would stall. To make things worse, recycling isn't a viable solution yet. Only about 5% of titanium scrap is recycled worldwide. That's because aerospace and defense applications require ultra-pure titanium, which needs specialized refining. The West doesn't have the infrastructure to process enough of it at scale. The Pentagon is aware of the threat. It has stockpiled titanium for years, but even the most optimistic estimates say these reserves would last just 12 to 18 months in a crisis. Not nearly enough to survive a prolonged export ban. Consider the consequences. Boeing's 787 Dreamliner requires over 14 metric tons of titanium for its frame, landing gear, and engine parts. Any disruption in titanium supply could delay production by up to 5 years and cost billions. Lockheed Martin's F-35 fighter is even more vulnerable. Its airframe is 40% titanium by weight. The Pentagon estimates that titanium shortages could slash production by 30% within 2 years, crippling NATO's air readiness. Construction and energy sectors would also feel the pinch. High-performance alloys used in bridges, industrial machinery, and offshore platforms depend on titanium. In nuclear reactors, its corrosion resistance is critical for pipes and cooling systems. Swapping to steel or aluminum could raise project costs by up to 30% or compromise safety. Wood. McKinsey analysts warn that a prolonged titanium crunch could inflate global infrastructure costs by over $10 billion annually.